Okay, you guys ready to get started? So last time we talked about, well, we had FedEx here last time we were here. Before that, we talked about sketching. So project update wise, I uploaded everybody's groups with the actual FedEx project that they chose. So I gave every group the first choice that they had, which meant that some projects got a lot more than others, but it really doesn't matter. It will be just as interesting to see how they turn out. Our next class on Thursday. Sorry. The syncing of Do Not Disturb is something that has not yet been achieved well. So next class, I'll take you through a project from a previous semester from start to end, so you can get a good idea of what that is. I realize you guys don't have yet like a concrete list of milestones and things that we'll be doing on the project. So for now, I mean, I assume you've all met with your groups and everything, and you kind of have ideas about what you want to do. Obviously, you can start sketching those out. You can even start coding them or doing whatever you want. But I'll take you through that. I'll also post kind of a rubric of just to guide you through it. I'm really flexible with whatever you want to do with this project. FedEx doesn't expect to receive like working code or anything like that. What they want to see is a concept. And they want to see a functional concept, but that doesn't mean it needs to have, you know, a scalable database or anything that actually would be used, because they'll just take from the concept and plug it into their system. So it's up to you to do as much as you want when it comes to things like databases and other coding aspects that are less user-facing. Certainly you'll want to do some of it. But I've seen groups do their entire project without ever having to really write much code that wasn't markup to make things look a certain way. So it's certainly possible, and I'll try to show you a couple of varieties of past projects and how that goes. We learned that FedEx wants pretty much everything to work on, I guess, every platform. So mobile devices, yeah, desktop. So usually, at least for me in my experience, that means moving towards a web technology, doing something that's just HTML, markup, CSS, JavaScript, because it's very portable, but they don't have to. If you want to make a separate Android app or separate iOS app or something like that, that's totally fine. We'll look more at, we're going to have 2 check-in points throughout the semester with FedEx. So the first one will be in a little over a month. I'll post it to the calendar. And that'll be, we'll have a class, probably 1 or 2 classes dedicated. They'll be on a video conference link with us, and each group will get a few minutes to present what they have and get feedback. So that'll help you kind of guide the direction you're going to go in when you're doing your project. And then we'll have that final checkpoint on the day of our final, which will be presenting the system to them. And so that combined with feedback that you'll get when you do kind of a user study and then just in-class stuff should allow you to make a pretty nice end product. I know that FedEx mentioned one of the projects having the in-location indicator. And actually, if any of the projects are interested in doing things with hardware that just aren't strictly software interfaces, if you want to do electronics, if you need to 3D print something, my lab has all of that equipment, and you're more than welcome to get in touch with me, and I'll set you up. We can print things, we can wire things, we can do whatever, if that's something that interests you. Certainly not required, but you're more than welcome to. So the class we met before FedEx came to give us the projects, we talked about what is a sketch, and we came up with these attributes of the sketch, which is basically that it's this quick thing that's disposable but meant to promote creating ideas for interfaces, for user experiences. And it's meant to capture that idea, to convey it, and then to elaborate on that. We talked about sketchbooks, and these are some example sketchbooks. All of you are encouraged to get a sketchbook if that's what you want to do. If you want to keep a digital sketchbook, that's fine. If you want to just have paper everywhere, that's also fine. Whatever you want to do there, there are a lot of options in terms of sketchbooks. We also discussed this design funnel idea, which will kind of stick to this idea throughout the course. And the idea is basically to elaborate and then reduce over and over until you converge to a single concept. So today we're going to talk about sensation and perception. And I'm going to start us with this short video. It's about the McGurk effect. And some of you may have seen this, but it's a 3-minute video, and I think you'll find it interesting.
At any one moment, we are being bombarded by sensory information. Our brains do a remarkable job of making sense of it all. It seems easy enough to separate the sounds we hear from the sights we see. But there is one illusion that reveals this isn't always the case.
Ba, ba, ba.
Have a look at this. What do you hear?
Ba, ba, ba. Ba, ba, ba.
But look what happens when we change the picture.
Ba, ba, ba. Ba, ba, ba. Ba.
And yet, the sound hasn't changed. In every clip, you are only ever hearing bar with a B.
Ba, ba, ba.
It's an illusion known as the McGurk effect.
Ba,
Take another look.
ba.
Concentrate first on the right of the screen.
Ba,
Now to the left of the screen.
ba.
The illusion occurs because what you are seeing clashes with what you are hearing.
In the illusion, what we see overrides what we hear. So the mouth movements we see as we look at a face can actually influence what we believe we're hearing. If we close our eyes, we actually hear the sound as it is. If we open our eyes, we actually see how the mouth movements can influence what we're hearing. Ba, ba, ba.
It's a bizarre effect. Remember, the only sound you're hearing is bar with a B.
Ba, 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 ba.
What's remarkable about this illusion is even knowing how it's done doesn't seem to make a difference.
Ba. The effect works no matter how much you know about the effect. I've been studying the McGurk effect for 25 years now. And I've been the face in the stimuli, I've seen stimuli thousands and thousands of times, but the effect still works on me. I can't help it. The speech brain just takes in that information and doesn't care about what outside knowledge would bring to bear. Ba, 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 ba.
The McGurk effect shows us that what we hear may not always be the truth.
Ba,
But it also helps us to understand what happens when our senses conflict.
ba, ba, ba. When the brain has the conflicting information, it tries to make sense of that conflict. And depending on what type of modality is providing more, I guess, salient information, that information might override or at least combine with the other information.
So we can't always trust what we hear, because sometimes our sense of vision takes over, enabling us to maintain a coherent view.
Okay, so did everybody experience the illusion there? Anybody able? I've tried really hard to not experience it, and you can't. So that's one example of what we're going to focus on today, which is sensation perception. And basically today and the next lecture will be just about the human and human-computer interaction. so we won't think too much about the machine during this part. But the point is, and obviously you know from the fact that there are whole colleges and disciplines focused around the different systems that humans have, humans are complicated. And the things that they perceive are based on very elaborate systems that aren't always well understood, but are somewhat well characterized at this time. So that was just a simple example, and there are a ton more examples like that, and we'll look at some of mostly visual ones today. But we'll talk about sensation perception. And so basically, we have sensation, perception, and cognition. And some interesting artifacts there. Huh. They don't show up over here. Might be the projector. So sensation, in terms of studying sensation and perception, is largely a historical term. You can think of sensation as being kind of the raw inputs. So if you think of a person and just imagine like 5 senses, don't worry about the others, but just seeing, hearing, that kind of thing. The light hitting the eyes, or the sound waves actually vibrating within the ear. That would be sensation. For most purposes, sensation is not studied alone when we're looking at just humans. It's certainly looked at a lot if you're looking at things like computer vision or building imaging sensors, things like that. But from a psychological standpoint, sensation and perception get grouped pretty tightly. So perception would be the next layer of so you've got light, hitting your eye. Perception might be a color, like red, or the size of something that you're seeing, or an edge on something. Whereas with sound, a perception might be a tone at a certain frequency, or a combination of tones. Now, cognition kind of encompasses perception, because, like we saw in the video, we're having a conflict whenever we see the mouth moving one way and the sound making another sound, and it's shaping it. So this is a top-down cognitive process that's doing this in this case. So perceptions are not always kind of pure things that arrive. You can't think of necessarily like light going into the eye, then that becoming a blob of color, and then that being understood as this round thing, and then that being connected to, oh, that's a ball, and you can throw the ball, and you can do this and that. It's not always clear cut like that. And next class we'll talk about cognition more, and we'll see the overlap. But for now, just to understand that cognition and perception are closely tied together. Cognition is a broader umbrella of things, and perception is part of that. And sensation we'll kind of just ignore. So, and to give you an example of this idea, this is from a book. This is a really good textbook if you're interested in kind of perception and sensation at a lower level. It's just called Sensation and Perception. And this is the example kind of they give when they talk about studying sensation by itself. And you could look at A here, which is just a single dot, and you could claim that that's a sensation, but at the same time, you've already inferred a lot of things just by saying it's a dot, by viewing it as an item on its own. It's not just a pixel. It's not just a value. It has some meaning. And so you can certainly, as you progress, you have more of these dots, and if these dots were to start to move, you would start to think other things about them. And certainly when they start to make things like this, we start to think something else about these dots. And so the lines are really blurry there in terms of perception and how that goes in a hierarchy, which it's not super important for us, but just know that those things are all interlinked together. So today we're going to focus on perception. We'll focus on some of the biases that come with perception. We're going to really just look at vision today. We may, in another class, look at things like haptic and audio, I definitely would like to look at some audio stuff and haptic stuff. The textbooks at this point don't have a ton on that. There's a lot of research, so I'll try to get together some of the interesting stuff for us later to look at. But today we'll focus on vision. It's probably by far the most important thing when you're building an interface for someone. If it's not a piece of hardware that's mainly based on touch, if it's a visual interface, you're going to want to know these things about vision. We'll talk about structure. So kind of we'll look at some different examples of how structure matters. Color. So color is a huge area when you're developing interfaces. We'll talk about peripheral vision. And the bullet point there says it's poor, but it's not entirely poor. And so we'll expand on that a little bit. And we'll talk about visually searching through a scene or through an interface in most cases to find something. What we really want to remember is that perception is biased by a few things, and these are just three that I'm highlighting. Your past experiences, whether they're experiences that you kind of explicitly can remember and point to, or if they're just things that always happen. The context that you're in, and the goals that you have. So you can easily ask someone to pursue a certain goal, and they may miss other things that occur because they're focused on that goal. Similarly, if you're in one context, something may mean something and something else in a different context. So just to talk about vision and visual perception. So what do we see in the image? Anybody see anything of note? A dog. Okay. Yes.
Snowy rocks.
There's a dog. There's a Dalmatian in there.
A tree in the back.
In the back. Okay. Yeah.
Shadow.
Maybe like a sidewalk.
Yes. Okay. So there's the dog. If you didn't see it, this Dalmatian or his head here and legs, body is kind of that way. But yeah, give this image to a computer vision algorithm or any kind of artificial machine and ask it what it sees. And up until recently, and unless it's been trained specifically for this kind of thing, it's probably going to report that it's just a bunch of black pixel areas, splotches scattered throughout. But we're able to pick things out. Like we're able to say, oh, there's a sidewalk there probably. There's a tree kind of looking thing. And a big part of that is we know that we're supposed to make sense of this image. I probably wouldn't have shown you an image that didn't have anything in it of value. So we're going to talk about some principles that have to do with visual perception that are the reason that we can do things like this. But I'll give you a couple more examples. So what are these, I guess? H's. Yeah. What are they now? So for the most part, can we make out what it's trying to say to us?
Yeah.
The cat. Yeah, and obviously, it's the same symbol used for A and H in this case, but we're able to use the context around it to fill in that this should be an A. And I'm sure you've seen examples of things where you can misspell things, you can leave words out, and people won't notice. Certainly probably experienced it if you've written a few essays or a few papers and gone back or seen them graded later, and it's you proofread it, but you went right past something that because you filled it in. Okay. Anybody want to tell me what this says? Polish silverware. Polish silverware. So again, context matters quite a bit. And I think in this case, I guess it's ambiguous because, it's going to be uppercase no matter what. But the point here is that a lot of the things that we represent and that people perceive don't exist just in isolation. And so when we talk about design principles, we'll talk about being careful about things appearing in places maybe you didn't expect them to appear, and taking on a different meaning, that kind of thing. But the main point here is that humans are very context sensitive, so we can interpret this in multiple ways. Okay, have you guys seen this? So the lines are all the same length. Does everybody believe that? Do they look the same length? It's a little bit hard to tell, but they are. So this is, again, exploiting some of the visual principles that we work by that usually work very well for us, but kind of when they're pitted against each other, leave us some doubt. So we've got a few more of these. So all the lines in this image are straight. They look pretty straight from where I'm now. I guess they're curved. Do they look curved a little bit to you guys? They have kind of a, when I look at them on this screen, they have a little bit of a bulgy curve to them, but they're straight. This one is pretty compelling to me. I don't know. This one doesn't work so well on me, I guess. I don't know. It's a little bit, if I try to make it look like they're warped. This one works. The length. So in this case, you kind of start to try to perceive depth to this, and that confuses things a little bit. This is a good one. If you stare at that fixation point in the middle there, you'll kind of see that the circles appear to rotate. So one thing is that we tend to focus on our goals a lot. So in the previous slide, does anybody remember if there were scissors on it?
Yes.
Yes. What else was on there? Hammer.
I can't see them looking at all.
So yeah, you guys did pretty well, actually. Yeah. But yeah, we're goal focused. If there's something unrelated, we won't focus on it necessarily.
What's that one at the bottom? With the,
This?
like the shovel.
This shovel? I
What was
don't.
the other thing?
Yeah, I guess, yeah, just to like spread, yeah. That's some good clip art. I stole this from a different PowerPoint, but I should say that a lot of this content is from a book called Designing with the Mind in Mind, which I personally think is a horrible title. But it's a decent book, so in terms of talking about a little bit of how perception overlaps with UI design, it hasn't been updated in a while. So that's why I didn't want to say, like, go buy anything, really. But okay, so here's a website from a while back. And so if you wanted to find scholarship information, where is it easy to see where you would look? Where would you click on, possibly?
Probably scholarship tile.
Scholarship title, okay. So certainly, these are some of the places you could click. You could go to the search and just type it in. You could click on scholarships prominently in the banner there. Did anybody notice that we had won $100 down there? So things certainly can sneak by us, I guess. And there's a difference, I would say, between, like, this is a novel website for most of us. We have not visited this website before. We don't use it for anything that matters to us. Whereas if we were, I don't know, managing servers or something, and we had like a dashboard to tell us, the health or that there was a problem, we'd probably have a lot better of a kind of a muscle memory of where to look and what matters. But this is a search problem in kind of a novel environment. And so you can see there's not a ton on this page, and it's pretty decently, structured. It's not awful. It looks like a lot of, university websites might look, but it's easy to miss things, and certainly if they're hidden down there. So I'm going to go through some Gestalt principles of visual perception, and we're going to. There are a number of them. We'll look at these: proximity. We won't look at similarity in much detail. We'll look at continuity, closure, symmetry. We won't look at figure or ground, and we'll look at common fate. You can certainly look up Gestalt principles, and there are more or less of them that people have come up with, but these are kind of the main ones. So I'll start with proximity, and it's really simple. When things are closer together, we think they belong together. So in this case, these appear to be grouped into rows, whereas these are more grouped into columns. Although I wouldn't really, I don't know. The one on the right, do you guys think it's columns, really? It kind of looks even to me.
Not until you said something that I see columns.
Yeah, I guess it's columns. I have to measure it, but it almost looks even. But certainly when they're next to each other. These are rows for sure. And that's just because, there's more space between these two than between something like that. Pretty simple concept. So here's an example of proximity just in an interface. Essentially like this little grouping box, right? All of these things belong together. So I think this is from like Microsoft Outlook a while back. But it's helpful just to have this little kind of outline in this case to know that if you want to take action on any of these entries, these buttons are grouped with that rather than being for maybe the distribution list or something else on the interface. Here's another one. So this is the, I think this is Thunderbird on Mac or something. But essentially showing you that, again, things are grouped together nicely, like this set of buttons up here versus this set of buttons down here. Whereas, these are kind of your default actions, which is another thing we're all used to this kind of thing where the action button is down in the bottom right. How many people have experienced a scenario where they swapped these two buttons on you and you clicked the wrong one because they swapped it cleverly? So that's another one of the things that we'll talk about a little bit more about users forming habits and their expectations, and kind of trying to figure out when you're building something for a particular audience, what are those habits going to be? What are the things that they expect to happen? So let's see. Here's another example of proximity, and this is just showing you that by grouping things, you obviously get this nice separation. This is a lot more difficult to look at, and it would certainly be even more difficult if you didn't have the color to show you. Or this maintains the bold font, it maintains the underlines. If you were to take all of that away, proximity is going to be really important in terms of being able to easily search through this and find the information that you want to find. So this is an example that book gave of a bad proximity grouping. And so their complaint was, this is 3ds Max 6, I guess, and it's kind of like installing certain components of the software, and you've got these add remove toggles. But it is kind of the case that proximity-wise, these are grouped as columns, whereas they should probably be more on each row. I don't think it's terribly confusing, probably not terribly confusing for someone installing 3ds Max, but it's certainly something that's kind of easy. It's an easy fix to really improve comprehension of the interface. So similarity, I'm not going to go into similarity in any detail, but that's just to say that things that look similar to each other, people perceive them to belong together. And you can find a million examples of that in the world. So continuity. So if we cover this up, we pretty much all would think that this line continues through and this line continues through. When we look at it, we don't see it as, you know, a V of two colors, a V of two colors in a circle. We perceive it's a line of one color, a line of another color, and that they continue through. So let's see if we can. Yes, there we go. Wonderful animation. So, yes, oh no, he ran away. Okay. We all would perceive that, you know, there's more to this little creature than we're shown. In the same way, if you see like a slider like this, we are likely, so even though we can imagine this slider two ways. Okay, we could imagine that like it's discrete, so it just kind of snaps, right? Like you can choose 1 minute, you can choose 5 minutes, you could choose never, but you can't get in between there. In which case you could replace this with another interface, right? You could have like little radio buttons or something where you could only choose one of them. Now, when we add the slider, I mean, essentially it's the same thing, but the slider gives you a sense that, you know, this is all continuous. It's all part of the same thing. Now, if we were to let you kind of pick any point, then the slider becomes really essential because it connects this whole idea. And we see this kind of thing everywhere.
What's the scale between 5 minutes and never?
Yeah, right? Okay. Yeah. So that's a good question. I think this is probably, let me see what it says in my notes. Does not say. I believe it's from, it looks like a Mac, like power settings. Yeah. But yeah, that's a great question. And mapping out things like that is certainly interesting. Closure? Okay. So we'll kind of, when presented with ambiguous things, we solve the problem ourselves. So most of us probably see 2 triangles and 3 circles, and we assume there's some ordering, some layering of that going on. We probably don't see like this piece individually. This, you know, that's not our first inclination. Whereas an algorithm or a computer system would be more likely to pick out these components and then kind of do the higher level combination. This is another example of, you know, I mentioned that cognition and perception is kind of fuzzy, it overlaps, there's top down, there's bottom up, and it's not easy to say, oh, there's a certain point, you know, in my thought process where I see it as edges and lines before I consider it a full shape and then decide there's an ordering to it, that kind of thing. We certainly know things that, for example, you know, there are very specific neurons that fire for certain angles of edges. Okay, so that's something that we've been able to observe. But from that up to conscious thought, there's a lot going on that's not observable at this point. For us, it's important to know that people, we will try to create closures when we can. So another example of that, this is really simple. This is an icon. You know, we all assume there's a second letter back there. Obviously, there's not. But, okay. Symmetry. So we're all more likely to try to find symmetry than not find symmetry. And obviously, we always want to see the simplest figure rather than try to create a complex figure. Figure ground, common fate. So common fate is, it's kind of a combination almost of this proximity and continuity being merged together. So we kind of assume these birds are all headed in the same direction. Likewise, we probably assume, and this is kind of an interesting one because, you know, you might assume all the red ones are going to be headed in a specific direction or have a specific goal, and the black ones have a different goal. But you could also look at this, say if you didn't see it in color, and maybe think that this shape has some intention of its own. Obviously, this can be, if you put arrows on things, then we really expect certain things to happen with them. But this is something that, in general, people will ascribe a common fate to things that seem to be moving in the same direction or have the same goal or intention. Okay, so let's talk a little bit about structuring information. So the basic idea is that some structure is better than no structure. So here we have a very verbose piece of text telling us when our flight is. And here we have the same information formatted a little bit differently. So for the most part, humans tend to use a linear search method when they're looking for information, like in text or something, if they aren't given any other cues. So if we needed to know, where we were arriving, we would probably have to scan through a bit of this text to find it, more so than just looking at this arrow telling us that we're going to San Francisco. And this is a really simple thing. Not much has changed here. The font is bold. There's some space. You can certainly take this further. But the general idea is that in most cases, this representation is going to be superior to this representation. Now, where this gets interesting is if you're doing something that's not visual. If you're having a voice assistant tell you about something, this might be what the voice assistant says. And there's certainly interesting work in that in trying to get things like voice assistants to tell you exactly what you want to hear and not an entire verbose speech with extra information. So this is kind of the same thing. Obviously, we like to be able to kind of quickly scan through things. And so in this case, I believe the Designing with the Mind in Mind book calls this popping, which I'm not a huge fan of, but we can call it that. So like these headings kind of pop out compared to some of this other text. And most of us are pretty familiar with this kind of thing just from growing up and reading, knowing that we can scan through headings to kind of narrow down where we want to look for something. And so this can go further, obviously, with colors and shadows and outlines and all kinds of things that you might want to do to draw emphasis to something. Draw a circle around it. There's another example of structure. So this is a website, I think this is the California driver's license website from many years ago. So here's an example of just listing out all of your options that you have. Here's that same idea, but giving you kind of like this table-like structure to kind of look up in it, where you're looking, kind of at the action that you want to take, and then filtering down in that. We'll talk more about mechanisms like filtering and searching, and how we can do different things with those. Also things like if we're going to show a search result, we may not want to show the full entry of whatever it is that we're representing. So representing things in a way that is easy for the user to perceive and doesn't give them more than they want, but doesn't give them too little information. And a lot of that, honestly, is domain specific. So we're going to spend, several classes talking about all of these principles and, good design methods. But to be honest with you, a lot of this is about testing and seeing what works and what doesn't work. Certainly don't make this. We kind of know that. It doesn't work. It works, but it's not pleasant to use, and it's easy enough to do this. But there's a lot more than these simple text interfaces out there. And so a lot of HCI really is testing things. Certainly if you're out in industry working for a a large company or on a system that has a lot of users, testing is going to be a huge part of it. You're going to try different things. You're going to see how it affects response times. You're going to see how it affects people's engagement. And that's going to drive your decisions more than anything. It's not necessarily going to be understanding how the human visual system works. That may get you in the right direction, but there are all kinds of confounds that come up that you really only learn from testing. Let's see. Okay, so we don't really remember phone numbers anymore, but there was a time when people did. And so these groupings are helpful. It's easier to have this structure. In a similar way, if you're going to have to read a credit card number to someone on the phone, or you're going to have to give them a confirmation number, a lot of times putting it in these little groups is easier because you can kind of do it a group at a time if you have to convey it to someone. When we talk about cognition on Thursday, we'll talk about something called chunking. And so the idea basically is that humans are pretty good at remembering 5 to 7-ish, I think is the current research, things, chunks, they call it. And that's not really a set quantity. But in this case, you might be able to group, 4 of these numbers might be one chunk, basically, instead of 4 chunks for each digit. This was also a big usability kind of issue before everything was required to connect to a cloud to do anything. You had activation keys, and so those activation keys would often be split into chunks so that it was easier to enter in, because if you kind of just got the string here, you lose your place. It's just simple usability stuff, but it makes a big difference, especially if someone's going to be doing this over and over all day on an interface. So here's an example of an old web interface. I think for the most part, honestly, today I haven't had to enter a credit card number in a long time because everything is so nicely integrated to pay with Amazon or Apple Pay or whatever that it seems to just know. But most of the interfaces have gone to something like this, where kind of as the user types it in, it's splitting it up for them. Most of them will check it as you're typing it in, because in the case of credit card numbers, there's a really easy algorithm that you can check to see if the number is valid or not. Okay, so let's switch gears a little bit. Those were the Gestalt principles. Oh, I should mention, while I have you all here, we will have our first in-class quiz on Thursday. It will be about this stuff. It will be easy. Do not be afraid. Just try to remember some of these things. So, color vision. Humans, we see in color, most of us. And in the eye, you have structures called rods and structures called cones. You have 3 types of cones, and they're for each color, red, green, blue, light. And so the rods are for contrast rather than color. That leaves us with some interesting characteristics of human vision. And so we see contrast and relative contrast well. So we're not tuned in on an absolute scale to recognize things. That's why it can be difficult in some of those illusions to see that certain things are the same, because there are things in between them and they're not really relative to each other anymore when we're processing them. So let me see if I can give you, yeah, here's a pretty good example. So all of these grays are the same, and it's easy to tell, when you're at this point that these two are the same, but not necessarily between here and here. And that has to do with the fact that we really optimize around edges and contrast. And so that's kind of more prominent when we look at something. This has an interesting side effect, not just with color, but if you've ever designed an interface, or even just laying out something that's like a poster or a flyer or whatever you're doing, And like your software has like guidelines. So like when I make the presentation, right, I drag something and it snaps and it shows me this is center this way, this is center this way. Sometimes you can mathematically put everything in a way that is spaced nicely and is symmetrical, but if your content has certain properties, everything will look skewed or off. So there's kind of an idea of a perceptual centering of things and then like a true mathematical centering of things, and they're different. And so we'll see, this is kind of the case why a lot of icons or thumbnails, it's like if you think of like Netflix, like you're scrolling through all of the movies and shows that are on there, none of them deviate from filling a full rectangle. None of them have like some edges or transparency or anything, because that can really upset kind of the balance of how the overall interface looks. So there are a lot of things like that that have to do with the way that we perceive things, and kind of these optimizations that we make because of the properties of our vision. So this is a similar one. The inner gray is just one color gray, but we put this gradient behind it, and it's very tempting to feel like it is not always the same gray. This one gets me every time. A and B are the same, which doesn't seem right, but let's see this animation. So we'll just start covering things up. So there you go. It's upsetting, to say the least, but and this is from Cornell University a while back as a graphics professor who created this. But in this case, it's the shadows and the contrast that we're trying to kind of accommodate when we're processing this that doesn't allow us to see the true outcome. Okay, so important thing, if you don't gain anything from this course, this is the one thing you should at least walk away with. Some people cannot see all of the colors. So it's more prevalent in males. So about 8% of male population has some form of color blindness. Does anybody know anybody who is colorblind? Okay. So the most common is red-green colorblind. And this presents some issues. So it's hard to, kind of red-green is a default that a lot of things use, and that's really unfortunate. So it's something you've got to think about when you're developing an interface. If you're developing an interface for use with, a decent amount of people, the odds are against you on this one. You're going to encounter somebody who's colorblind that's going to use your system. There are people at FedEx who are colorblind that are going to need to use the systems you're designing. So you've got to think about that as you design them. So this is a just rendering of this website. This is what it would look like to someone who's red-green colorblind. There are a number of tools that you can use. So similar, here's the Google logo, old Google logo. But this is what it would look like if you were red-green colorblind. So there are some nice tools where you can put either websites or images or anything into them. There's even some software you can download that will let you change your whole computer so that you can experience the world as if you were any of the types of colorblind. There are a couple other types besides red-green. Red-green's really the only one that gets talked about a lot because it's the most prevalent. So it's really something that you have to think about when you do something like this. And this is not just because we have some of the population that's colorblind, but it's also because sometimes this happens and things get printed out or otherwise rendered on something that doesn't support color. And suddenly all of your information is lost. So this is the reason that if you're ever making a graph or something, please don't ever use color to distinguish two bars or something. Use color plus like a fill pattern or something, just so that if that color channel is not available to whoever's looking at it, they still can get the information. So you want to try to use colors that are distinguishable even when they're viewed by someone who can't see the full spectrum of color, or on a display or something that doesn't render the full display of colors. So what actually works really well, honestly, is just to throw things into grayscale and to see what it looks like. If you can pick out the differences between areas on a grayscale rendering of it, you're usually doing all right. So the Designing with the Mind in Mind book says that 12 colors are the most colors you'll ever need to use in one place. I don't know if that's true. It sounds like a lot of colors, but maybe it's not enough colors. I'm sure there are many exceptions to this idea. But certainly we've all seen interfaces and art that has gone too far with color or any other element. So being conservative is not a bad idea. Start small and work your way up. So some specific recommendations. I think the most important thing that you can remember is to be redundant when you use color. Color should never be the primary way of indicating something. It's really useful when you have it, but you don't always have it. You can also use their like 1,000,000,001 tools now, where you can go and kind of dial in a color and then ask for complementary colors or monochromatic scales of it. When we get into like actually prototyping interfaces and stuff digitally, we'll look at a ton of those tools, and if you guys have tools that you like, we'll post those, and then that way we all kind of have a bunch of options there. But there's those tools will help you avoid all of these problems. But just on a basic level, kind of remember that if it were in grayscale, it needs to look okay. And so this is a guideline of, I guess, good colors that go together. There's also some subjectiveness to this. So, okay, this is good stuff. Let's talk about peripheral vision. So here is this simple login, which for best results recommends Netscape Navigator 3 or higher. But the idea here is that someone has logged in, and we have helpfully put this error message up here, just kind of in plain text. And so the idea being that this is probably not the best way to convey that information. What's said a lot in HCI about peripheral vision is that it's poor, in the sense of you can't really read, in your peripheral vision. You're not going to absorb a lot of detail, and that has to do with just kind of the physical hardware of the eye and the way that the brain processes that data stream. So you kind of have a much denser sensing area, without getting into it too much, in the fovea of your eye. So wherever you're kind of directly fixated, that's obviously where you're going to be able to like read words and see details more so than as you work your way out. So there's also kind of an argument that this data is uncompressed versus the peripheral data being compressed. And so half of the visual cortex is dedicated to those fovea areas. Now, can anybody think of an example of peripheral vision being really important? Motion, yes. Those are both very good. Motion is the main one. So it's become really common now. on your desktop to see a little alert slide in over there, right? Or on your mobile device, pop down like that. None of those are where you're fixated, but they're really good at getting your attention. We're really good at detecting motion around us for survival reasons on the most fundamental level. But while that data is compressed and it's not high resolution, it's great for getting our attention. And so that's something to think about too when you're designing an interface. If you don't need the user to attend to the information immediately, you just need to let them know there's information for later, it's probably best not to pop up in the middle of whatever they're trying to do and frustrate them. So here are some examples of if you focus in on those center points, you'll kind of get this blurry effect on the outer. This is an example of, it's an exaggerated example of what is going on whenever a user is like focusing on the login button here. Essentially, this information, you shouldn't imagine them being able to take that all in at its highest fidelity while they're trying to find a target. So, kind of the advice for if you really need the user to get information, you've got to put it right where they're looking if they need to consume that information. But if it's something that you just need an alert or a notification, it's fine to slide in on the sides and kind of give them that state information. Just know that it's not a lot of information you can convey. So in some cases, I think, like for the most part, most notifications on modern systems have like the icon of whatever app or software is trying to tell you something. We're able to kind of know the ones we care about, but it's not a guaranteed thing. At most, there's an alert. So they specify this as heavy artillery. So popping up something, usually a last resort today. Audio can be useful, and we'll talk about haptics and vibrations being useful because that's a big part of today's mobile devices. But certainly you do not want to make audio a core part of an experience that is not focused on audio. So your FedEx apps probably will not contain a lot of audio alerts. And then, of course, there's animating things, which can be wonderful or horrible. My suggestion is make it short if you're going to do it. So, like, for example, the Mac operating system, if you type your password in wrong, the little box kind of just shakes at you, which is cute, and it gets the point across. But there were versions of iOS, for example, where there was quite a bit of animation of opening apps and closing apps that frustrated a lot of people. So it's a balance with animation. Certainly less is better usually. There's some error symbols for you. Okay, so here's another idea if you want to convey information. This is pretty common when we fill out forms today. It validates as you go. So in this case, you get to see the feedback right where you're working. So that kind of solves these problems. Here is that login screen, which the book has hopefully improved, although the background has done something. So in this case, instead of putting the message up there where no one will read it, they put it in red, which may or may not be helpful, and then they've kind of highlighted the invalid fields. So let's talk about visual search briefly. Where's Waldo? Did you find him?
To the right. To the right.
Oh, well, it's not him. No, ignore him. This is just yes, that is him. So I will solve this for us. He is right there. So this is an interesting problem, so much so that we've created a successful product based on it. No, I think it's the same picture. It just jumped. I think the color is
Down left near the wall.
The
Yeah.
color changes. That's trippy.
oh, interesting. Okay. So that is an interesting artifact of moving things from PowerPoint to Keynote, I would imagine. Huh. Maybe. Yeah, it's taking out the red. Yeah, good. Yeah. it's trying to help us. There we go. Okay. So here's another one. Find the guy in the red shirt. It's a little bit easier because he stands out. So as humans, we do tend to linearly search these kinds of scenes. Not always, but if it's just complete chaos and uniform noise in the scene, we'll kind of scan it. Okay, so these are kind of fun. So find Z. Everybody find Z.
Found it.
Found it. Okay, so we're pretty quick at finding it. So find the bold letter. A little bit faster at doing that. Yeah. So in this case, it's the same type of information. When we're searching for bold versus non-bold, obviously that's pretty easy to segment, whereas if we're searching for a specific letter. Okay, how many L's are there? Yeah. So this takes a while. You really just have to, count them. There's not necessarily a good trick to it. Anybody want to guess how many there are?
7.
7. There are 7, yes. Or so I'm told. I don't know. I count them. Okay, so counting the blue letters. This is easier than finding the L's, obviously. So these kinds of different channels of information basically are helpful. When we get to cognition on Thursday, we'll look at when this kind of stuff can mess with each other and bad things can happen, and it's a lot of fun. So here's a similar visual search. Find the orange dot. That's pretty easy. It's still pretty easy. Still pretty easy. Still pretty easy. It gets harder the more of this that you add in. So the more variation that you add in, certainly as your hues get closer to orange, you're going to have more problems. So, similar way when you do a visual search, if you have a nice clear hierarchy, it's easier to find things than if you just slam all the text together. When we're looking at something like a drop-down menu, for example, if you wanted to insert a table, the first time you see this menu, you're going to have to search through it to find it. So you can see, there are some groupings here, right? Media kind of stuff, like movies and sound. Some basic, slide operations. This kind of all gets thrown together. But one thing to know is that even if you create something like this, users will learn how to use it. They'll find the thing they need. But they're going to remember that. So when you update this thing, please don't put that thing somewhere else, or gradually put it somewhere else, because that kind of thing becomes a problem. Humans are very adaptable, most adaptable part of the interface, but they certainly get set on doing something once it works, and breaking that is obviously horrible. Here's another example of visual search. So this is a network, a data center monitor kind of interface. And in this case, it's pretty easy to see, based on color in this case, where you've got problems. In a similar way, this data is nicely grouped and segmented. You've got your graph data here, you've got the geographic info here. So it's nice and grouped. It's not all just run together. You're seeing emphasis on the things that you need to see. You're not overwhelmed necessarily. Another example of visual search is something like this, where we've got these apps, and they're in alphabetical order. But the huge thing here that, I guess software has had for pretty much as long as the GUI's been around is everything has an icon. It has a symbol representing it. So in this case, if, you're familiar with Firefox, you're probably not going to have to even go through the alphabet if this is all you're looking at. You're going to be drawn to that visual symbol. And so that's something to think about too. You kind of want to be redundant in the way you do this. Okay. So that is all I have for today in terms of sensation and perception. We'll talk about cognition not on Tuesday, on Thursday. We'll have a quiz that will be easy. Just, remember some things about Gestalt principles. Remember about, using color in interfaces and that some people can't see color, and you will be fine. And that's everything I've got. So I'll see you guys on Thursday.